Okay, for this last entire section, we're going to go through a series of slides and we're going to ask questions and then give the answers. And so I would like for you to get a paper or something and answer the questions on the piece of paper and then stop the tape. Well, stop the tape and answer the question before you reveal the answer. Now, I'm not going to stop talking, and so you need to control this by answering or stopping the tape. Now, if you don't do it this way, you're not going to get the full benefit out of going through this section. And also, it might be helpful to go through this section more than once as a form of review. So here's the first question is that why, write on your paper, why these two compounds or these two structures are not isomers. The answer is that the one on the left has a double bond and therefore has the formula of C6H12, whereas the one on the right does not have a double bond and has the formula of C6H14. And an isomer are two compounds that have the same formula but different structures. And so that's why these two are not isomers. So give the IUPAC name for this compound. Now, if you look at this, the parent compound, you can either be drawn from here up this way and then this way, or it can be drawn from here across. So it's 1, 2, 3, 4, so that's butane. And then here you have a methyl group, so it's methylbutane. Now, since if you put it here or here, it would still be 2. You would just count from one end or the other. You don't have to use a number. So this is, you could say 2-methylbutane, but the 2 is superfluous. It's not necessary. So it's 2-methylbutane. Give the IUPAC name for this compound. Okay, again, you need to start and count, and you should start either here or here and count 1, 2, 3, 4, 5, 6, 7, 8. So this is octane, but now you have a triple bond here, so it's YNE, octine, and you have a fluorine here. Okay, so you start counting on the end where the triple bond is. So it's 1, 2, 3. So the fluorine's on the 4th carbon here, right? So you have 4-fluoro, and you also have a methyl here, so it's 4-fluoro, 4-methyl, 1-octine. The 1, or you can put the 1 on the end to show that the triple bond is on the end. So 4-fluoro, 4-methyl, octine. Here's another one. You start here or here and you count 1, 2, 3, 4. So this actually has the same formula as the 2 slides ago. So it's again butane with a methyl group here. Okay, so it's going to be 2-methylbutane or just methylbutane. 2-methylbutane. Let's do this one. You start on this end or on this end, and you go 1, 2, 3, 4, 5, 6, 7, 8. So it's octane, but it's got a double bond on the first carbon. So it's 1-octene, ENE, and you have to start counting from this end. So it's going to be 1, 2, 3, 4, and there's a methyl group, 5, 6, and there's a 7, and there's this bromine group. So it's 4-methyl, 7-bromo, 1-octene. 4-methyl. Okay, so they're saying that this is on this carbon instead of this carbon. If I gave you this on a quiz or a test, it would be more clear which carbon this is associated with. How about this one? Well, it's got the answer already given there, but if you count it, it starts here, 1, 2, 3, 4. so it's butane, but it has an OH, so it's butanol, but it's not on the end, it's on the second carbon, so it's 2-butanol. It's not 3-butanol because you always pick a number that ends up with a smaller number. Okay, here's another one. If you start counting on this end or on this end, it's 1, 2, 3, 4, 5. So that's pentane. And now you've got an OH on the second, so that's pentanol, 2-pentanol. And you've got iodine here and 2 methyls here. So you've got 2-iodo, 3,3-dimethyl, 2-pentanol. 2-iodo, 3,3-dimethyl, 2-pentanol. Now here's another one. Now this one, just looking at it, you should be able to tell that it's a ether. And there's two ways you can name this. One is you can look at this and say this is a methyl and this is a 4-carbon butyl, so you can call this ethyl butyl ether, or you can count the whole thing, 1, 2, 3, 4, 5, 6. So ethoxybutane. Remember, you use the longer chain as the base chain, so this would be butane, ethoxybutane. So it's either ethoxybutane or ethyl butyl ether. Now I'm not quite sure why. Oh, the reason there's a 1 there is to tell you that this oxygen bond is on the end of this chain as opposed to being on one of these 2 carbons. If it was on either of these 2 carbons, then it would be 2-ethoxybutane. Now here's another ether. Now how would you name this? Now again, the dominant chain is on this side and it's propane. So it's either going to be 1-ethoxypropane or it'll be ethyl propyl ether. Now if it was on this carbon, it could be ethyl isopropyl ether or 2-ethoxypropane. But in this case, it's 1-ethoxypropane. 1-ethoxypropane or ethyl propyl ether. Now, order the above from the least oxidized to the most oxidized. Now you remember that the least oxidized would contain no oxygen, so that was going to be B. The single oxidation of B results in an alcohol, which is A. And you have 1 oxygen with an H on it. Then it will be oxidized further to form the, in this case, ketone. So you go from B to A to C, and then you can't oxidize this any further because of these 2 methyl groups. So you can't form an acid unless this oxygen is on the end. So it's B to A to C. So what is the oxidation product of this compound? The oxidation product of this compound, first of all, let's name this compound. It's 3 carbons, 1, 2, 3, and you have the carbonyl group on the end, so it's an aldehyde, so it's propanal, Al. If you oxidize this, you will put an oxygen right here and form an acid, propanoic acid, which will have an OH here instead of the hydrogen. And so it's going to have this formula, CH3, CH2C, and then the double bond O is going to be here, and then the OH is going to replace this single H here. Predict the oxidation product of this, the single oxidation product. You start out, again, you have 3 carbons, so this is propane, but it's an alcohol, so it's propanol with OL. You do a single oxidation, you'll drop this hydrogen and form a double bond here, and so it's going to be a aldehyde, propanal, and it'll look like that. What is the reduction? Okay, a single reduction of this. Now we're going to go the other direction. So instead of forming, if this was being oxidized, we'd be forming an acid. We'd be going from an aldehyde to an acid. But if we do a single reduction of an aldehyde, we're going to form an alcohol. So we're going to go from ethanal, this is ethanal, Al, to ethanol, Ol. And it's going to look like that. What happens if we reduce this? The same thing that happened in the previous, except now we're going to be in the middle. First of all, we start out with propanone, 3 carbons with a carbonyl group in the middle, so it's a ketone. So propanone. This ketone then becomes an alcohol when it's reduced, and so it's 3 carbons with an alcohol in the middle. So it's either 2-propanol, OL, or some people would call this isopropyl alcohol or isopropanol. Why are these 2 products not isomers? Well, this is kind of a trick question, because basically all we did was turn the corner here. But remember, you don't have to pick up your pencil with either of these, and therefore they are essentially the same structure. So again, isomers have a different structure. They have the same molecular formula but a different structure, but these 2 compounds actually have the same structure, so they are not isomers. The bend is of no relevance. What is the IUPAC name for this compound? Now, if you look at it carefully, you see that you have 1, 2, 3 carbons. So this is going to be propane, but it has a double bond. So now it's propene, and it has a chlorine. So it's chloropropene. Now the question here, and it's interesting what the answer will be, is this could be a geometric isomer. Remember, what's the difference between if it had the chlorine here as opposed to down here? So it's trans chloropropene. Trans chloropropene. Now, the 1, there's a question whether the 1 is actually necessary. I would say yes, but it's certainly this one. This is the answer that's in the answer book in your book. This one is not necessary, because if you put the double bond here or the double bond here, it doesn't matter, okay? On the other hand, I think the reason they put the 1 in is to show that the chloro here that's trans to this, the double bond has to be here because if it was down here, then it wouldn't be trans anymore. And so that's why the 1 is on that, and then this 1 tells you this chlorine is here and not down here. So trans 1-chloro 1-propene. Now this one is, the answer is given here. It just looks complicated. The hardest part about this is not to get confused that whether you start here and draw straight across this way, or start up here and draw down and then across, or start here and draw down this way and then down this way, you end up with the same name no matter what. And so you have 5 carbons, so propane. Then you have a methyl group here, so 2,2, and then another methyl group, 4, trimethyl propane, or pentane, excuse me. I keep getting propane and pentane mixed up. Sorry about that. So what's the IUPAC name for this compound? Well, The IUPAC name for this compound, again, you have to decide where you're going to count. If you count from here across and then down, or from here down, over and down, you get the same number of carbons, which is 6. So this is hexane, okay? But it has an OH, so it's hexanol. And it has a chlorine, okay? So let's just go this way. So you have 1, 2 hexanol, and then 3 ethyl chloro. So it's going to be 3 ethyl, 3 chloro, 2 hexanol. 3 ethyl, 3 chloro, 2 hexanol. This is another ether. It has a methyl group and a propyl group. So you can either call it methoxypropane, 1-methoxypropane, telling you that it's on the end of the propyl group, or it's methyl propyl ether. So it's either 1-methoxypropane or methyl propyl ether. What is the oxidation product of this? A 4-carbon compound, so it's butanol, excuse me. It will single oxidize to form a double bond oxygen at the site of the OH, which is on the 2nd carbon. So it now a carbonyl group in the middle, so it's a ketone. So this becomes butanone. So it goes from butanol to butanone. And this would be CH3, CH2, CO, H, and then CH3. The reduction product of this is acetic acid or ethanoic acid. You remove 1 and you end up with 2 carbons and a double bonded oxygen. And so it's going to be ethanal, or CH3CHO.